Hello. Today we're going to focus on finding the molar mass of a compound. So what we're looking for is the number of grams that 1 mole of a given compound is equivalent to. So we're going to have to find that number using the periodic table. And before I go to my periodic table, I'm cheating here a little bit and filling in the rest of the information. Okay. So the way we're going to find it is we're going to look up the individual atomic masses of each of our two elements. We have hydrogen and we have oxygen. Pulling up my handy dandy periodic table, I see that hydrogen over here, the atomic, whoops, that's a little weird. Okay, hydrogen over here, the atomic number is right below, the atomic mass is right below the word hydrogen, and it's 1.00794. Now, depending on which periodic table you're using, it may round somewhere differently. Okay. As you notice up here, our hydrogen has a 3 behind it. That subscript tells us that we have 3 hydrogens. So to figure out the total mass of the 3 hydrogens, we're going to multiply the weight of 1 hydrogen here by 3. Using my handy dandy calculator, I can determine that 1.0000794 times 3 is going to give me, I really hate that about the calculators, 3 point, that doesn't look right, 3.02382. Okay, so the mass of all 3 of our hydrogens together is going to be 3.02383 grams. Next, we need to figure out what to do with our oxygen. So going back to our periodic table, we look for oxygen, and we find oxygen over here has an atomic mass of 15.9994. So each oxygen weighs 15.9994 grams in a single mole. Since oxygen doesn't have a number after it, it's by itself, or the equivalent of times 1, which is equal to 15.9994 grams. And to figure out the total, we are going to take 3.02383, and we are going to add that to 15.9994 grams. When you add those two together, you get 3.0332383 plus 15.9994 will give us an answer of 19.02323 grams of 19.02323 grams of hydronium give us 1 mole. Now, if we're going to be accurate about this, we have to make sure it's within the right number of places. So the one that has the least number of places is oxygen here, with 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4, 5. So technically, 1, 2, 3, 4, 5. We take that off. So what this is telling us is if we needed to measure out 1 mole of hydronium ion, if we measured 19.023 grams of that, we would have the right amount. Here's another example. Common sugar is C6H12O6. So following the same pattern, let's find out what the atomic mass of carbon is, hydrogen, and oxygen. On your periodic table, we find that carbon is 12.0107. So 12.0107. Hydrogen is 1.0079. And oxygen is 15.9994. Since the carbon has a subscript of 6, we need to multiply this mass times 6 to get our total mass. So 12.0107 times 6 is going to give me 72.0642. So 72.00642. Hydrogen, we're going to multiply by 12. So using our calculator again, we would enter 1.0079 times 12 gives us 12.0948. 12.0948. And oxygen, we are going to multiply by 6. Oops, I've been forgetting to keep up with my subscripts. Okay, so you got 12 there, which is why we multiplied by 12, and 6 here. So 15.9994 times 6 gives us a total of 95.9964. 95.9964. To get the total mass, we add up the 3 of them. So 72.0642 plus 12.0984 plus 95.9964 gives us that 1 mole of C6H12O6 equals 180.1554 grams of C6H12O6. I hope this has made learning about molar masses a little simpler for you. Goodbye.